drew. And then if we were to do a chair flip, we could easily get the most. We could get the other less stable version. So that would just look like this. So the one which was here is going to get moved down to here. So wedges up, dashes down. So this is now going to go on an equatorial up, and then this one's also going to go up. I just realized that I made a mistake. Not in the way that I drew these, but in the way that I phrased it earlier. So it turns out that these are actually going to be of equal stability because this is on an axial position and this is an equatorial position. And then when we do the chair flip, this is an equatorial position. This is an axial position. So they're both. So you would probably find both conformers of these in equal amounts. Now if we were to look at what the trans looks like, so this was cis 1. This was cis 1,4 dimethyl hexane. So here's trans. So here's trans 1,4. So now we're just going to draw the trans version of this. So the trans version is just going to look like this, where we have our we have our little hexagon going on, which isn't my best hexagon that I've drawn. So here we got a methyl group here. And we have a methyl group here. If we want to label this, we definitely can. Is Me for methyl, or we don't even have to label them. But the idea though is that now, when we draw this, we can draw the left leaning one first. So draw the left leaning one. This one's short. And this one's long, this one's long, and then this one can be short. So we have 1, 2, 3, 4. So this is on a dash going up. So it means that this one is going to have to go up like that. Okay, and then the wedge is down. So here, it'll look like that, okay? Now, both of these are axial, so not very stable, right? So they're not very stable. But what we can do is we can easily do a chair flip, and because I told you in the previous video that if it was axial, it now becomes equatorial. That's the rule for when you do a chair flip. So I'm telling you right now that that if you do a chair flip of this, you'll get the most stable isomer of 1,4 dimethyl. This should say dimethyl cyclohexane. So, right, so when you draw this, it'll look like that. And this one's going to be long, short, or long, and then short. And then the numbers change a little bit. So that means that our 1 is now going to be over. One's now going to be over here. Then you have 2, 3, 4, 5, and 6. 2, 3, 4, 5, 6. So now what's going to happen is, and we're saying that this is our 1, this is our 2. So 1 was going up. So so this is our 1 in an equatorial position, and then our 4 is also going to be in an equatorial position, like this. So here you can clearly see that this one is more stable, and you know that's more stable because it's in a because both of the because the only substituent both of the substituents are on equatorial positions. So now we can clearly state that when we look at the cis version, in which both chair conformations are equal, but then when we look at the trans version of this, in which we have a very stable conformation, we now know that trans is more stable than cis for this case. And specifically, we know that the left, it's the left leaning, it's the right leaning, it's the right leaning trans 1,4 dimethyl cyclohexane